Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle, and inside the circle we have a rectangle in the red color, and the center of the circle is at point O, and this line segment is 6 units and this line segment is 3 units. First of all, we will name this point M. So line segment CM equals to 6 units. Line segment CM equals to 6 units, and we will also name this point N. So again, line segment AN equals to 3 units, and actually OA is the radius of this circle because of the fact that this line segment OA starts from the center of the circle, that is to say from point A, and ends at point, that is to say from point O, and ends at point A, that is a point on the circle itself. For that reason OA is the radius of the circle, and OC is also the radius of the circle for the same reason, because it starts from point O, that is the center of the circle, and ends at point C, that is the point on the circle itself. Okay, so actually, because of the fact that OA and OC are both the radiuses of the circle, we can say that OA equals to OC. Okay, that will be our first equation. OA, this is the radius, equals to OC, that is also the radius of the circle. So our first equation is OA equals to OC. Okay, OA equals to OC because of the fact that both of them are the radiuses of this circle. Okay, and we will define line segment OM as Y, and we will also define line segment ON as X. Okay, so we have the equality that OA equals to OC, but OC is Y plus 6, so we can substitute OC by Y plus 6. OC, we can substitute OC by Y plus 6. OC equals to OA, and OA is X plus 3. So we can substitute OA in equation number 1 by X plus 3. So actually we got the equation number 1 that states that X plus 3 equals to Y plus 6. Now we will subtract 6 from equation number 1. So actually X plus 3 minus 6 equals to X minus 3, and Y plus 6 minus 6 equals to Y. So in total we will get that Y equals to X minus 3. Okay, again, Y plus 6 minus 6 equals to Y, and X minus 3 plus x plus 3 minus 6 equals to x minus 3, so we got that y equals to x minus 3. So actually this is a rectangle, and in a rectangle the parallel sides are equal to each other. So if side OM is y, then side NB of the rectangle is also equals to y. Okay, but we know according to equation number 1 that y equals to x minus 3. Okay, y equals to x minus 3, and actually OAO or OA is the radius of this circle, yes? But OB is also the radius of this circle because of the fact that it starts from point O, that is the center of the circle, and ends at point B, that is the point on the circle itself. For that reason, line segment OB is the radius of this circle. So OB equals to OA because both of these line segments are the radiuses of this circle. So if OA equals to x plus 3, then OB, that is also the radius of this circle, will be equal also to x plus 3. Okay? So actually the angles in a rectangle, the four angles equals to 90 degrees. So actually angle ONB is also equals to 90 degrees. Okay, so this is a right angle. So actually triangle ONB is a right triangle because this angle is 90 degrees. So in the right triangle OBN, in the right triangle OBN, we can use the Pythagorean theorem in order to find out the value of x. The hypotenuse of the right green triangle equals to x plus 3. This side equals to x, and this side equals to x minus 3. So we will use the Pythagorean theorem in order to find out the value of x. And you should remember that the radius of this circle equals to x plus 3. So after we will find the value of x, we will add to the value of x 3, and we will get the radius of this circle. Okay, so according to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB squared, that is the square of the hypotenuse, equals to the sum of the squares of the perpendiculars. That is to say, OB squared equals to ON squared plus BN squared. Okay, I will write it down. So that will be our second equation. Our second equation is the square of the hypotenuse, that is OB squared, equals to the sum of the squares of the perpendiculars, equals to ON squared plus BN squared. So our second equation is the implementation of the Pythagorean theorem in the right green triangle OBN. So second equation states that OB squared, the square of the hypotenuse, equals to the sum of the squares of the perpendiculars to ON square plus BN square. But we know that ON equals to X, OB equals to X plus 3, and BN equals to X minus 3. Okay? We know that OB equals to X plus 3, ON equals to X, and B equals to X minus 3. So we can put this data in equation number 2. So we will get that OB square is X plus 3 square equals to ON square, that is X square, plus BN square, that is X minus 3 square. Okay? Again, OB equals to X plus 3, so we substituted OB by X plus 3. ON equals to X, so we substituted ON by X, and BN equals to X minus 3, so we substituted BN by X minus 3. We got that X plus 3 square equals to X square plus X minus 3 square. Now we will open the brackets in equation number 2 from both sides of the equation. So actually we open the brackets of X plus 3 square. X plus 3 square equals to X square plus 9 plus 6X, according to the formula that A plus B square equals to A square plus B square plus 2 times AB. Okay, so we got that X plus 3 square equals to X square, that is A square, plus B is 3 square, 9, plus 2 times AB is 2 times 3x, it is 6x. This equals to x square plus x minus 3 square equals to x square plus 9 minus 6x, according to the formula that a minus b square equals to a square plus b square minus 2 times ab. So x is a and 3 is b, so x minus 3 square is a squared, that is x squared, plus b squared, that is 3 squared, that is 9, minus 2 times ab is minus 2 times 3x is minus 6x. Okay, so here in the second equation we have x squared in this side of the equation and x squared in the other side of the equation, so x squared is cancelled. We have 9 in this side of the equation and we have 9 in the other side in the equation, so 9 is cancelled. And we have 6x that equals to x squared minus 6x. That is what is left from the second equation. So from this side of the equation we have only 6x. This side of the equation we have only x squared minus 6x. So in total we got that 6x equals to x squared minus 6x. Now we will subtract 6x from the second equation, from this second equation. Six x minus 6x equals to 0. We have x squared minus 6x minus 6x is x squared minus 12x. Okay, again 6x minus 6x equals to 0, and x squared minus 6x minus 6x is x squared minus 12x. Now we'll take x as common factor out of equation number 2. Again, we will take x as a common factor in equation number 2. We'll get that x minus 12. So we took a common factor x from this equation. We got x times x minus 12. So we have actually two solutions to this second equation. The first solution, x equals to 0, is impossible because x is the actually the side of the rectangle, and it can never be 0. The side of the rectangle must be a positive number. So the first solution is impossible. X equals to 0 is impossible. The other solution is that x minus 12 equals to 0. Okay? X minus 12 equals to 0, so x equals to 12. X equals to 12. Okay, so we got that x equals to 12 units. We got that x, the side of the rectangle, equals to 12 units. But we know that the radius of the circle equals to x plus 3. So the radius of the circle equals to x plus 3. That is to say, it is 12 because x equals to 12 plus 3 units equals to 15 units. Okay, so the radius of the circle equals to 15 units. So that is the answer to the question. The answer to the question is that the radius of this circle equals to 15 units. Now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. Inside the circle we have a rectangle, and we know that the center of this circle is at point O. This line segment is 3 units, and this line segment is 6 units. We defined this point as M, so MC, line segment CM is 6 units, and we defined this point as N, so line segment AN equals to 3 units, and then we defined line segment ON as Y, and line segment ON as X. So actually OA, line segment OA is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point A, that is a point on the circle itself. For that reason, line segment OA is the radius of this circle, and also line segment OC is the radius of this circle because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is the radius of this circle. So OA and OC are both the radiuses of this circle. So we can write the first equation that states that OA equals to OC because both of them are radiuses of this circle. Okay? So OA, but we know that OA equals to x plus 3. So we can substitute OA by x plus 3, and OC equals to y plus 6. Y plus 6 is OC, so we can substitute OC in the first equation by y plus 6. So in total we got that x plus 3 equals to y plus 6. We substitute 6 from this first equation. We got that y equals to x minus 3. Okay, so actually because of the fact that this is a rectangle, so if this side of the rectangle equals to y, so this side is also equals to y because the parallel side in a rectangle are equal to each other. And also all the angles in a rectangle equals to 90 degrees, so also angle ONB equals to 90 degrees. And so if this side BN is y, we know that y equals to x minus 3, so we can add here that y equals to x minus 3. And actually OA is the radius of this circle, as I already told you, because it starts from the center of the circle and ends at point A, that is a point on the circle itself. For that reason, OA is the radius of this circle, but it equals to x plus 3. But OB is also the radius of this circle, so because of the fact that it starts from point O, that is the center of the circle, and ends at point B, that is a point on the circle itself. For that reason, OB is the center of this circle, is the radius of this circle. So because of the fact that OA equals to x plus 3, it is the radius of this circle, OB also will be equal to x plus 3 because it is also the radius of this circle. So those two line segments are equal to each other because of the fact that both of them are the radiuses of this circle. So if this radius equals to x plus 3, so this is the radius, and this also will be equal to x plus 3. So actually we know in the right triangle BON that this side is x, the hypotenuse is x plus 3, and this side of the right green triangle equals to x minus 3. So we actually can use the Pythagorean theorem in the right green triangle in order to find out the value of x. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, OB square equals to ON square plus NB square. Okay, but we know that OB equals to x plus 3, ON equals to x, and BN equals to x minus 3. Okay, so according to the Pythagorean theorem, OB square is the square of the hypotenuse equals to the sum of the squares of the perpendiculars equals to ON square plus BN square. That is the second equation. But we know that OB equals to x plus 3, so we can substitute OB by x plus 3. We know that ON equals to x, so we can substitute ON by x. And we know that BN equals to x minus 3, so we can substitute BN by x minus 3. So we got in the second equation that x plus 3 square equals to x square plus x minus 3 square. And we actually solved this second equation and we got the final result that x equals to 12 degrees. Okay, x is the one side of the rectangle, but the radius of this circle equals to x plus 3. So the radius of this circle will be equal to x, that is 12 units, plus 3. 12 plus 3 equals to 15 units. So the radius of this circle equals to 15 units. Okay, thank you very much.